Let us investigate the RO membrane, what are the constituents of RO membrane and how RO process works in a RO based purifier. For this purpose, we will look inside a RO pressure vessel or a RO cartridge. You can see a RO cartridge in my hands. This was sealed cartridge. I have cut it carefully to take the RO element from this cartridge or pressure vessel. This is the pressure vessel, this is the RO element. The pressurized water is fed from the exposed end. This is the exposed end, feed end, and the permeate or the RO water comes out from the sealed nozzle. You can see this is the feed end. The general misconception that water can go in. No, this is not a possibility because it is not going in. So if we check, this is sealed here. So main process that happens in this region. So this is the core. Core is having some holes and the membrane is attached to it. So the collected water means the RO processed water goes through the pores and collects from this nozzle. This nozzle is again sealed by the two O-rings or gasket. This ensures that this RO water cannot mix with the untreated water, because when you pressurize water sent from the feed end, in the RO process 65% of the water comes out from here untreated region and goes to the rejected water. Only the remaining 35% collected after the purification. You can see a black color rubber, which is a seal which fits tightly on the walls of RO cartridge from inside or the pressure vessel. The purpose of this valve or seal is to prevent the pressure feed water to go in the rejected water without treatment. Because you can see, if I fit like this, water is feeding from this end. So what you can see, as soon as the pressure increases, this expand and this seal become more prominent. So you can see there is a gap. So water, if you increase the water pressure, this seal become more prominent and it doesn't allow. You can see inside in the center, this is the center which is for the RO water, and there is in corner there is a small hole. You can see this hole. This is for the rejected water. So what happens, the rejected water comes out from here and the RO water comes out here, and there is a provision to seal it from the gasket. There you can see one cylindrical thing is there that ensures that RO water is coming out from this path and rejected water goes to this path. So you can connect this rejected water to your toilet water or something for toilet use. So the 65% water that comes out from the rejection will be used for toilet, and you can use the RO water for drinking. Now come to the design of the RO membrane and how it's engineered to treat the feed water. An RO membrane consists of 3 layers. We come here. An RO membrane, which is this, consists of 3 layers: polyester, polysulfone and polyamide. Polyamide layer is the main layer, which is called the barrier layer, and it is 0.2 micron thick. This barrier, it is the polyamide layer that removes the nutrients, germs, bacteria, virus from the feed water. Though RO membrane consists of 3 layers, strength is not sufficient to sustain the feed water pressure required for the process. To make the membrane useful, an intelligent engineering is required, in which feed water pressure won't be much effective to destroy the membrane. For this purpose, RO membrane is bounded spirally on nylon nylon polyamide or PP. This is polypropylene or for this purpose, the RO membrane is bonded ultrasonically on the edges with a permeate spacer. So you can see this is a RO membrane, this is a permeate spacer, and there is one more RO membrane. So two RO membranes are sandwiched on a permeate spacer only on the edges, which are forming a envelope like structure or a sealed structure, which is also sealed on the edges of this core here on both sides, and also it continues to the other end. So you can see up to here, this is sealed at the corner. This membrane is RO membrane, and in the center, on the center you can find this is the permeate spacer or the pure water spacer, from which the water collects till the core. So water goes through this route all over the membrane, and there are pores in the core, and that water goes in and collects from here. We have already discussed this end is closed from here, so there is no water can flow that side because this is closed here. We have already shown this. So this is the how the RO membrane is engineered to collect the water. Now how the feed water can interact to all the surface area, for that purpose they provided this spacers. This is the feed water spacers. So there are two in numbers. One is for this one and one is from this side, and they can be rolled together. So if I provide one spacer here, one spacer here, and then I can roll it, then it will form a structure which will look like this. So this is the structure. This is done by the machines. This we cannot apply by hand, that much pressure, so it will form this structure. So this is the feed water channel, and this permeate spacer is the RO water channel. This is a core, this is a feed water spacer which is outermost, then innermost is the RO membrane with this is a two-sided RO membrane, and it sandwiches the permeate filter in between, and then after this there is one more feed water spacer, and there is one more membrane, which is this is a permeate spacer, and these are two are the membranes. So same thing but twice, and there is one more spacer, and now we roll it. So if we roll it, so the outermost one will provide the, if we roll it completely, there is some trapped air because of from the pore holes, some air can be trapped here, so that we cannot avoid manually if we are doing it manually. But you can see the structure is forming, and the feed water can go through this channel, and the role of this structure, it will distribute the pressure uniformly and also water uniformly to hold the surface of the RO membrane. That reduce the risk of the fouling of the membrane when you feed high pressure, which is required for the RO process. For a more clear vision, I am again opening this see it carefully. I am opening this. So what can be taken out is the two feed water spacers, one from the outermost and one is in between the two RO membranes. This one I have taken out, and now you can see what is done here. This is the core, which is nearly in the center, and there are two membranes, basically four membranes, which out of two are sandwiches, like one sandwich, and this is a one slice of the sandwich, and it is sandwiching the permeate spacer. So this is the permeate spacer, this is the RO membrane, this is the RO membrane, two RO membrane, and this is the permeate spacer, which is like ultrasonically bonded on the edges. So it is forming an envelope kind of thing, envelope structure at this end, which is opening to the pores of the core, and the core is sealed at here, but it is open at this end, from which the RO water can be collected. What I have shown you, that there are two RO membranes. One is this RO membrane, as this RO membrane. This sandwiches the permeate spacer or the RO water spacer. This thing is sandwiches here, means, and there are two feed water filters like this. So feed water filter are shown here. Feed water spacer, you can see here feed water spacer,